The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, everybody. This is the 10th safety law that we are going to discuss today. My name is Dr. Susanna Gyenes. I'm the deputy to the director of the iChemist Safety Center. And before I start with the topic, I would like to let you know that this is the final safety law so far. We have published 10 of these safety laws, and all right. And after this, the next law will be published in September. And in parallel with this topic that I brought to you today about alarm management, I would like to kindly inform you that the iChemist Safety Center working group, one of them, is working now on a guidance document on alarm rationalization. And this document will be most probably available by the end of the year or earlier next year. And it will provide practical solutions, practical tips and recommendations how to rationalize your alarm system. It's because it was discovered by the iChemist Safety Center companies that alarm rationalization is a topic, is an issue. It's an ongoing problem that is the problem. And in fact, the problem is inherited from previous occasions, and that the fact that the plants are operating and they've been operating for a long time, and alarm management is necessary. So today we are talking about key lessons from incidents related to alarm management, and as it was usual, that please feel free to add your questions in the question box, and also if you have any further recommendations, tips that you would like to share, then please feel free to again use the question box. And a final announcement basically is that we are going to come back with different topics on different webinars. So please just check on our website and LinkedIn, where we will post all these upcoming free webinars, not only the safety law. It's, as I said, this one is the last one that I published, but other topics which might be really interesting to you. So what is the case? What's the situation with alarm management? Alarm systems, why are they so important? Alarm systems are important in monitoring the condition of the plant. Alarms assist personnel to maintain a system or process within a safe operating envelope. The objective of alarm management is to provide operators with a consistent and reliable action event notification interface that supports operators in their efforts to operate the process while ensuring they are not overwhelmed safely and efficiently with unnecessary information. This is, as you usually discover, that this is the starting point where I give the frame of the whole topic and try to explain what we are going to achieve here. I brought 2 case studies which show why alarm management is important and what can happen if there is a problem with alarm rationalization or alarm management in general. So the first case is about a gas plant. A major explosion and subsequent fire occurred in a gas plant. 2 people died and 8 were injured in this incident. The plant had been suffering from operational upsets following pigging of the upstream gas pipelines. A warm liquid, which is called lean oil, system failed, allowing a metal heat exchanger to become intensely cold and therefore brittle. When operators tried to reintroduce warm lean oil, the vessel fractured and released a large quantity of gas, which found an ignition source and then exploded. I would like to introduce some of these key learning points, and as usual, you will find the detailed key learning points in the PDF version of the safety law on our website. I will give you the link later on during the presentation. The direct cause of the incident seemed to be loss of lean oil flow leading to a significant reduction in temperature of a heat exchanger. What happened on the day? The lean oil recovery system, which extracts liquefied petroleum gas from the condensate stream, had tripped, and the plant operators were struggling to restart production. It was common that many process alarms were activated at one time, many of them considered to be nuisance alarms. There was lack of identification of safety critical alarms. That resulted in slow response to the loss of oil flow. Operators were basically expected to deal with at least 300 or 400 alarms a day. I mean, that's quite a significant number. A past incident occurred in the plant where investigators revealed that for a 12-hour shift, 8,500 alarms went off. What does it mean in operation? It means 12 alarms in every 60 seconds. Operators followed a practice, therefore, to silence the audible alarms and switching the visual ones from flashing to steady state. In addition to that, the display could only contain a certain number of alarm signals. Once that number was exceeded, existing alarms would be hidden by a new page of alarms, making it impossible for operators to follow up on the current situation. So when we go to the What Can I Do session, which is the second part of discussing the safety law, I will highlight these aspects about the display, about the design, and the fact that how operators were really overwhelmed by this huge amount of number of alarms. And it is not their fault, basically, that they just followed such an unfortunate procedure that they silenced the alarms and switched the visual ones from flashing to steady state, because otherwise they couldn't handle the situation. But there were other aspects, of course, as it is the case with all the case studies, to consider in the recommendations. So there was no investigation followed up by that incident, or there was no follow-up action basically after that incident that occurred earlier. The second case occurred in an oil refinery. A lightning strike started a fire on the crude distillation unit. The ensuing plant disturbances and power interruptions affected the vacuum distillation, alkylation units, as well as the fluidized catalytic cracking unit, or FCCU, where the explosion occurred, resulting in the release of 20 tons of flammable hydrocarbons from the outlet pipe of the flare knockout drum of the FCCU. In this case, 26 people were injured in the incident, and the explosion caused significant production loss. Also, the first case has very massive consequences, and also an interruption of the operation. So this is also something that we can take home as a message, that all these accidents can occur, and then also the consequences and the impacts both on the environment, both on people and the reputation of the site, the operation, can be really, really devastating. So all cases that we've been discussing in these last 10 occasions actually demonstrate really well that really accidents are really expensive. That's the end of the message, basically. But what are the key learning points in this particular case study? So in terms of alarm management, because as I mentioned, all these cases have different aspects in the investigation, and therefore you can pick many recommendations from these investigation reports. In terms of alarm management, the large number of control room alarms during the process upset conditions made it difficult for operators to assess and reflect on what was happening. After the investigation was done, it revealed that too many poorly categorized alarms overwhelmed the operators as the process upset developed. You see, there is a parallel with the first case study, where also there was no prioritization of alarms. Observations from the distributed control system alarm records indicated that during the incident, alarms were being presented to operators at the rate of 1 every 2 or 3 seconds. So it's quite overwhelming, such as it was in the first case. In the last 10 minutes before the explosion occurred, the two operators had to recognize, acknowledge, and take appropriate action on 275 alarms. Alarms going off this frequently resulted in operators cancelling them because of their nuisance value without necessarily recognizing what they meant. You see the parallel again. As most alarms were assigned the same high priority, virtually all were presented on the area alarm summary, and operators were unable to tell which alarms were critical to safety and which were not. Again, another parallel aspect with the first case study. Furthermore, there was no philosophy for determining what priority an alarm should have, and no control was exercised over the number of alarms in the system. The use and configuration of alarms should be such that safety-critical alarms, including those for flare systems, are distinguishable from other operational alarms. Alarms are limited to the number that an operator can effectively monitor, and ultimate planned safety should not rely on operator response to a control system. Each alarm should have a clearly defined purpose, such as safety, equipment failure, abnormal process conditions, or product quality. The correct number of alarms should be determined by operability criteria. Preferably, there should be as few safety-critical alarms as possible, and these should be limited to those situations where a wider knowledge of the process conditions is required than can be provided by any automatic protection system. And now we arrive to the part where I'm discussing the what can I do session. So what can you do as a manager, as a process safety engineer or supervisor, and what can you do as an operator in order to avoid that such accidents occur in the future. And all the what can I do recommendations that you can find in the PDF version of the safety law are around the ISC 6 elements, which you can see on this slide, that we believe that these are the 6 elements, the key functional elements is vital to achieve good process safety outcomes. And all are pinned around leadership, because in every aspect and area of these 6 elements, leadership is a crucial one. So what are the 6 elements? Just as a reminder for those of you who haven't been here before: systems and procedures, engineering and design, assurance, knowledge and competence, human factors, and culture. And as you can see in the PDF version of the document, once you downloaded it, and please feel free to share it with your colleagues, with your clients, everybody, because it is also free to download, that all of the recommendations and each and one of them are associated with a particular element that is relevant for that topic or for that area that I'm discussing with these recommendations. Okay, now what can I do as a manager? A lot, in fact. And also, I just go through these tips, but once you downloaded the document, the PDF version, then you will be able to see that these are really in detail, so that you will find all the detailed information about these what can I do sessions. So the use and configuration of alarms should be such that safety critical alarms are distinguishable from other operational alarms. Alarms are limited to the number that an operator can effectively monitor, and ultimate planned safety should not rely on operator response to a control system alarm, and alarms must have a specific action required. Make sure that the company has an alarm philosophy in place and keep it up to date. Make sure to implement lead process safety metrics to measure the performance of the alarm system together with regular audits taken place. Now, this is the point which I mentioned earlier, that the ISC will come up with a guidance document, a very, very practical one, a short supplementary guidance document on process safety lead metrics. And the working group is working now on identifying those topics and challenges with alarm rationalization and how they can be solved and how they can be measured by different metrics, and what are the metrics that they can use to address that particular area of interest, and to see what is possible, what kind of safety metrics can be applied to identify that particular challenge. So other things such as design. So display systems should be designed to provide an overview of the condition of the process, including, where appropriate, mass and volumetric balance summaries. So how many times we've heard the phenomenon of blind operation, or that was a problem with the display system, so that operators didn't see what was going on in the plant, what were the operating process conditions, what was the temperature, the pressure within any reactors. This is a really significant part, that you have a feedback to the display and that you can see and get the information that is necessary for the operation. In case of normal operation, especially in startups or shutdowns, and of course emergency situations. What else? Make sure that alarms are prioritized and there is adequate time for the operator to respond with defined prioritization rules based on the potential consequences if the operator fails to respond in the correct time. I would like to highlight this because as I read through investigation reports, I found it really surprising or shocking or interesting, but in fact it was the case that there was alarm management in place, but as such that it didn't give operators adequate time to respond. This is something that operators should consider, that even though there is an alarm philosophy, even though these alarms are prioritized, that's all good, even though they are on the display and operators can see what is going on in the operation, but they have to have adequate time to respond. And coming back to the prioritization, it is best to do it proportionately. So for instance, it's just an example, 5% of high priority, 15% medium, and 80% low. You may come up with different numbers. This is just to give you an example, to give you the idea behind. Improving alarm management has to continue through the life cycle of the plant, and it should be addressed in the management of change and the plant safety management system to maintain control and ownership. This is a really practical example of as I mentioned in the creeping changes webinar, that whenever you switch from analog to digital, whenever you change something in the system, and this is particularly valid for control rooms, where you upgrade the system, electronic system, the devices, the displays, all these different instruments that you have in place. Also, when you change your alarms, then it is really, really crucial to go through a management of change procedure, so that you avoid such cases where you change something and then you change another one and another one on the original design, and then they are not tackled and they are not addressed in the risk assessment and the management of change procedure. And then it comes to the point where these changes accumulating and then an accident is there and it's been waiting for happening. What else you can do as a manager? Investigate and this is again something that is valid for all of these safety laws, that investigate all incident or near misses. This is crucial. Investigate all of them where operators missed alarms or initiated an incorrect response. Ensure new alarms or modification of the existing systems are covered in management of change. Now, this is what I addressed in case of when you want to follow up and when you want to address creeping changes as well. Make sure that there are enough operators and supervisors to manage upsets properly and that they are there when they are needed. I will highlight this aspect more. Set up clear roles and responsibilities for normal and abnormal conditions and have a thorough training system in place to ensure that supervisors and operators have the adequate level of competency. And in order to be able to do that, the iChemist Safety Center also published a very, very good guidance document on competency, which is also available for free for everyone. And I didn't mention earlier, but of course, the new lead metrics supplementary guidance document on alarm rationalization, when it will be published, all together with other publications, the early concept design phase that is on our website already, and also the permit to work systems that we are now working on in terms of process safety, lead process safety metrics will be published later by the end of the year. They are all accessible for free from our website, and I really encourage all of you, if you find them really interesting or useful in your operation, please feel free to share all this information among your colleagues and clients. As I said before, I can't highlight it enough because share the information, not only the storytelling part, but share all the knowledge, information, background, guidance documents, literature with your colleagues is really, really crucial so that we have the knowledge to be shared with others. So what can I do as a process engineer and supervisor? These are just a couple of recommendations, tips, and you can find more obviously from your operation, which I would love to hear from you. So if you started thinking about what else could be, then by the end of this webinar, please feel free to share with others, because these webinars are not only me talking and providing some information that may be useful for you, but it's also a platform, an opportunity now to share best practices or good practices, whatever terminology you prefer to use, with each other, and or ask questions even from each other, because I may not be able to answer to those specific questions about why this or why that on alarm management happened or didn't happen. But if you are able to share it with your colleagues who are on this call, on this webinar, then that would be really good to see. So, a process safety engineer supervisor point of view. Check if operators experienced being overwhelmed by alarm floods. If there are nuisance alarms, for example, large numbers of alarms acknowledged in quick succession, or if audible alarms regularly turned off. Make sure that the operator training covers topic of how to handle alarm floods, and if operators know what to do with each alarm. Ensure that operators report all upsets in the process and that those events are investigated. Make sure that operators understand and follow the alarm prioritization and action rules. Make sure that there are enough operators to manage upsets properly and that they are available when they are needed. This is the point which I presented also under the management responsibility and under here as well. Track alarm data and metrics and review to see where alarms can be rationalized. And also, I haven't mentioned it here particularly, but when you go through those lead metrics, please from time to time review them, whether they cover all the topics, all the issues that you may face during operation in terms of alarms or not. And if there is something that is missing, then try to identify that particular metric. Or you try to also basically rationalize your metrics, because you may have like hundreds of metrics, but if you don't use them effectively, then you don't need that high number of metrics. This is something that you can get information also from the original ISC guidance document on lead process safety metrics. So that you have to know what you measure and why do you measure that, and how to present the information and what does it mean that you measure. So this is also valid for alarm rationalization. And then of course we have the operator part, and I've come up with a couple of tips, recommendations for operators. And again, if you have more, please just feel free to share with me and with others. So make sure that you know what to do with each alarm and have a clear understanding of alarm prioritization. Again, this is training, competency, skills. Check if the control room displays are well laid out and easy to understand, and that support is available, written or on screen. Make sure that you can easily navigate around the alarm pages and that all terms used on screen are understood and clear. If unsure, ask the supervisor. And make sure that your roles and responsibilities are communicated clearly, both for normal and abnormal conditions, and that you are trained what to do in such circumstances. I think I've highlighted in every safety law how communication is and training is a really, really important aspect in safe operation. And in this case, is also really important because operators, once they don't understand, or if they don't understand what to do with each alarm, and they just automatically by reflex, they just silence those alarms without even thinking or considering why they do it, and they didn't tell or they don't tell to the supervisor, hey, this is a problem, I can't see the display, or I can see only these numbers of alarms showing up on display, but I can't see more. So then there you have a problem. So clear communication is a crucial aspect. I haven't specifically written it down, but I think if you think about it, this becomes really obvious that ask questions if unsure, check if operators are following all the procedures. First of all, if you have procedures, if you have alarm philosophy, if those alarms are rationalized, prioritized, and make sure that you have refreshment trainings, newcomer trainings, and also when you exercise the emergency response plan, then you also consider to exercise the alarms, so how they are handled in case of emergency. I haven't specifically turned the information in this law on that, but just to think about the whole topic basically gives you the idea of how wide is this area and how it is interlinked with other practices and other operations within the plant. Because and again, I am repeating myself, but this is what I would like you to take home as a message, that the whole plant is a system. It should be handled as one system, and not only that, okay, I'm responsible for this unit and I don't even know anything about production. I'm just an emergency response team member, or vice versa. But you have to have a general understanding what is going on in the plant, what is linked to which operation and why it is happening. So it's not that you have to know everything in depth, but at least give just get the general idea at least. And in order to help you with identifying what are your competencies, then you can read through the competency document with the matrix inside, and you can identify what are the topics and what is the role that you are working in, and what is the level of competency that you need to be able to complete that particular job at the adequate level. So this was this lore about alarm rationalization or management. You can find the podcast in MP3 format again for free, again to download on this particular link. And we will publish soon the Spanish version of this safety lore, the same website where we published the English version and all of these past safety lores and podcasts. So feel free to visit our website for further information, and stay tuned for the future webinars that we will be running throughout summer. So the work is not done, and in fact, we will run a webinar on process safety metrics, lead metrics, the supplementary guidance document on pressure relief devices. So if you are interested on that, please feel free to visit again our website, which you can see here, www.ichemysafetycenter.org. And you can find us on different forums. As always, I will publish this safety lore on our YouTube channel, and I will share also the video on the LinkedIn. If you have questions, I'm happy to take. I don't see questions. That was a question about how was the first case situation regarding the alarms ever have been allowed to have occurred. That is a good question that I think the investigation report might be able to answer that, because I have to, normally I don't reveal which accident I was talking about, but that was the first one, was Longford. So if you are interested what happened in Longford, there are numerous number of publications about that. If you don't have any more questions, then I would like to thank you for your kind participation today, and basically hopefully see you in next webinars. So thank you so much if you don't have any other questions. Thank you. Bye bye.